All right, let's say we're asked to factor the expression 6x cubed y squared plus 3x squared. The first thing you always want to look for in factoring when you have two or more terms involved like these, we've got term 1 over here on the left, and we've got term 2. We want to see if the two terms have anything in common. We're looking for what is called the greatest common factor. If there's a common factor, then we want to take that out. That's the first step here. So in a previous video, I had found the greatest common factor of these two terms. And I can do it here just by inspection. I see that they do both 6 and 3 share a factor of 3. 3 is something that they would have in common in their trees, in their prime factorizations. So I definitely want to have that be part of the GCF. And I can keep as many x's as they both share. So whoever has the lowest number of x's, that's the number of x's I'll keep. So notice that there's 3 x's here and 2 x's here. So how many can I keep? Just 2. 3 would be too many because they wouldn't all have that in common. See, it's got to be something they have in common. Now, what about the y's? Can I keep any y's? The answer is no, because they don't have y's in common. Only one of the terms has them. So my GCF is 3x squared. Now that I know that, I can go on to the next step of factoring, which is to write the original as it is. And now we want to make a change to it. We're going to multiply the GCF on the outside. But then what we'll do is we'll divide each term by the GCF as well. See, multiplying and dividing, those are operations which would cancel each other out. So I haven't really changed the expression. All I'm going to do is change the form of it into a factored form. So I just have to bring down that 3x squared. And we need to put the results of the divisions into the parentheses. So 6 divided by 3 makes 2. X cubed divided by x squared makes x. And the y squared has to stay because there's no y's in the denominator. And of course, 3x squared divided by itself is 1. And it's done. It's in the factored form now. Now, some people don't show that middle step. Some people will just jump to the final answer from experience. And if you've been doing this a while, then you may be able to be at that step. But I assume that everybody who watches this video is not experienced with this technique. So it's best to show that middle step if you need to, just to show why we get to those final answers of 2xy squared plus 1. But here we can check our answer. The way we check it is to send the 3x squared back into the parentheses through distribution. So I'll actually multiply 3x squared times 2xy squared. And I'll just do it in my head here. 3 times 2 makes 6. X squared times x. Well, that would be 3 x's. And then just tack on a y squared there. Then we'll do 3x squared times the 1. You have to put a plus between them. And that's just going to be itself. And we can see now that it actually looks just like the original had. So that shows that we did it right.